The first technique in this lesson is the factor and cancel technique. The factor and cancel technique gets rid of an indeterminate form that looks like 0 over 0 by finding a common factor of the numerator and denominator, which makes both expressions 0. The idea is we factor the numerator, factor the denominator, find something which cancels. Hopefully by making that thing cancel, we'll prevent the top from being 0 and also prevent the bottom from being 0. We use this technique whenever we have a fraction where both the numerator and denominator are polynomials. If we don't have a polynomial, we can't factor, so we cannot use the technique. The steps involved in the factor-cancel technique are as follows. The first step is to make sure that the numerator and denominator both yield 0 when plugged in. If we don't get 0 over 0, we do not need to use this technique. The second step is to factor the numerator and denominator. Again, we can use various factoring techniques to factor those polynomials. The third step is to find any common factors and cancel them. If we don't see anything that cancels, we probably have not factored enough. The fourth step is to replace x with whatever it approaches again and see if we can get a value. If we get a value, that is the value of the limit. If we get 0 over 0 again, we have to go back to the beginning and do the same thing. We'll do a couple examples of factor and cancel here. The example 1 has the limit as x goes to 1 of x squared minus 3x plus 2 all over x minus 1. So the first step is to replace x with 1. We get 1 squared minus 3 times 1 plus 2 over 1 minus 1. 1 squared is 1, minus 3 plus 2 gives you 0. 1 minus 1 gives you 0. We've got the indeterminate form 0 over 0, so we know we need to use this technique. So we're going to factor the numerator and factor the denominator. We factor the numerator, we get x minus 2 times x minus 1. The denominator is already factored, we just have x minus 1. These guys cancel, so we get left with the limit as x goes to 1 of x minus 2. Now this limit we can evaluate easily using the limit laws by replacing x with 1. We get 1 minus 2, which gives you negative 1. So the value of this limit, the limit as x goes to 1 of x squared minus 3x plus 2 over x minus 1 gives you negative 1. Example 2 is going to be a little bit more complicated. Again, the first step is to replace x with the value it approaches. X is approaching negative 1 here, so we get negative 1 squared plus 2 times negative 1 plus 1 on the top. On the bottom we get negative 1 cubed plus 1. Negative 1 squared is 1, plus 2 times negative 1 is minus 2, which gives you negative 1, plus 1 gives you 0. Negative 1 cubed is negative 1, plus 1 gives you 0. So we have 0 over 0, so we can use factor and cancel. Again, the limit as x goes to negative 1 stays in front. Factoring the top gives you x plus 1 times x plus 1. Factoring the bottom using the sum of cubes formula gives you x plus 1 times x squared plus x plus 1. The x plus 1s will cancel. We can replace x with negative 1 now. We get negative 1 plus 1 over negative 1 squared plus 1 plus negative 1 plus 1. Negative 1 plus 1 gives you 0. Negative 1 squared is 1 plus negative 1 is 0 plus 1 gives you 1. 0 over 1 gives you 0. So the value of this limit is in fact 0.